There was one mistake in the previous computation. When we operated the third row, we take 2 times the third row minus 5 times the first one. So here we have 2 minus 5, 2 minus 5, which is not minus 2, but rather minus 3. And then to get 0 here, we must take 3 times the second row to subtract from the third row, and then we get minus 10 instead of minus 6, and then the result is 20 divided by 4, which is 5, which is in agreement with the other way how to compute this determinant. Before we compute the determinant, we can prepare the matrix in still another way. The determinant does not change if we add a linear combination of some rows to a given row, or if we change a column by adding a linear combination of another columns. So here we can, for example, subtract the first row from the third one. Then the determinant will be, we copy the first row, 2, 1, 0. Well, and we can take the second row and we can subtract the first one. And then we get 3 minus 2, which is 1. 1 minus 1 is 0. That's good. 2 minus 0 is 2. And now we could copy the third row. And then we can subtract the first row from the third row, and this will go to 5 minus 2 is 3, 1 minus 1 is 0, and 1 minus 0 is 1. So we have taken the second row and we subtracted the first one, and we subtracted the first one from the third as well. This is not Gaussian elimination to bring the matrix to the upper triangle form. This is just a convenient pre-processing before we evaluate the determinant by another method. And now, you see, we have a column with many zeros, and that's good. Then we can expand the determinant along this column, and we get minus 1 times the subdeterminant generated by deleting the first row and the second column, which is 1, 2, 3, 1. Well, and this is easy to compute. Well, and then there would be plus 0 times something, plus 0 times something, but this contributes nothing. And this is 1 minus 6, which is minus 5, times minus 1 is plus 5, in perfect agreement with the previous 2 ways how to evaluate this determinant.